Our question is going to be if f of x, which is a function, and what is that function? The function 3x squared plus 2x over x, and that it happens when x value is not equal to 0, and the k value when the x value is equivalent to 0. And what is our main question? Our main question is going to be what must the value of our k value what must the value of our k value be equivalent to in order for the function f of x to be a continuous function f of x? Well, before we solve for this question, we need to think about what this question is about before we apply the stuff we can know in order to solve for this question. And the first thing that we can talk about is analyzing the problem. We are going to talk about analyzing the problem, what this question is about, before we think about applying the things that we know before we solve for this question. And the first thing that we might see is the word f of x. And what does the f of x stand for? Well, the f of x is same thing with f, which is our output of our function, plus our x value, which is the input value of any kind of systems of patterns, and that will gonna give us f of x. And what is output plus input generates? Well, it will generate a specific function that satisfies its own equation. So the f of x, since we saw the f of x, this question is going to be about the function problem. And there is a specific function that is given. What is this specific function that is given? It will be 3x squared plus 2x over x. And as we can see, there are totally two cases of our x value, which we're just going to call it as the domain of our x value. So there are totally two domains of our x value. First is when the x value is not equal to 0. And the second case is when the x value is equal to 0. First case, where the x is not equal to 0, is a general case of our function, which is 3x squared. If we write it down, will be 3x squared plus 2x over x. And as we have talked about this in a lot of videos, we know that this is a f of x, which shows that it is a specific function. It is a specific function that shows that it is f of x. But this is a function that is formed by a specific fraction. And what is the fraction? For example, fraction is a stuff that looks something like this. Let's say x over y, where it is formed by the numerator, which is the part in the top one, and the denominator, which is the bottom one, which is the denominator. And if we add all of the cases of our numerator and denominator, we'll be able to get what we call as the fraction. And the fraction in this case is a thing that is consisted of our function f of x. So our f of x is a function that is made up with the fraction. So from here, we might think about the definition of our function. What is the f of x, which is the function that contains a specific fraction? Well, we call it as the rational function. We call it as the rational function. What is the rational function? It is a function system that is made up with a specific fraction, which is the numerator and the denominator. So this question is basically about the rational function. So the first thing that we need to talk about is what is the definition of our rational function, and what is the most important thing in our rational function. And as we have talked about this in a lot of times, the definition of our rational function is going to be any types of function that is formed by a fraction. So any types of function that is formed by a fraction is going to be what we call a rational function. So we have talked about the definition of our rational function. So we need to talk about what is the most important thing in our rational function. Well, as we can see, the most important thing in a rational function is the systems of our limits. So the most important thing in our rational function system is the system of our limits. And so this question is every single question, they mostly 100%. of our rational function problem is about the limit systems. So as we can see, the limits is super important, and we need to think about firstly, the first thing that we need to talk about is the definition. So definition and types of our limits of our continuous function. So our definition, so our first thing will be, what is the definition of our limits? What is the definition? The definition of our limits? Well, the definition of our limit is going to be any types, the limits, the definition of our limits is going to be any types of our values. So it'll be any types of our values, so that means it can be either the values or the answers, but there are that a function or a sequence which shows this y value approaches. So what is a function sequence stands for? They stands for the y value. And as the y value approaches some specific value, the input value, what is the input value when you apply to our function? Well, it will be our x value, which is the input, not an output of our function. And as the input approaches our undefined values. The undefined values is the most important thing in our limit systems. And the limit's definition, if you convert it again in an easier words, that means as a function or a sequence, which we'll just notate as the y value approaches some specific values, our most important thing is our input value, which we call it as our x value, approaches our undefined values. What is the definition of our undefined values? Well, the definition of our undefined value is when we input some specific values, the output of that value is going to be 0. This is what the undefined value is going to be. And this is also a definition of our systems of our limits. And it is the most crucial thing in our rational function. So as we have talked about this, the second thing that we might need to talk about is going to be the types. So the types of our limits. Types of our limits in our rational function, which is a function that is formed by a fraction, the numerator and the denominator. So totally, there are two cases. There are two types of our limits in our rational function, and we can think about its value through its definition. What did its definition said? It is a value that a function or the sequence contains. So the first case is going to be what the function is. Second thing is what the sequence is in our types of our limits. So depends on times, there will be obviously going to be different formulas. And since we knew that is a limit, the formula always contains the limit value. So let's think about the first case. The first case's formula for our limit system is going to be when the limit value, we use our lim to show limit, and when our x value, which is input, approaches our c value, and we will contain a f of x that is equal to b, which is our first formula for our limit system. What is this formula about? Well, this formula is about a function in our limit systems. And how did we know it? Well, we know that the function stands for, or we note it as our f of x value. And in the first case, they wrote the f of x, and they also wrote the x value, which is the input of our function. So that's why this is a function of our limit. Now let's think about the second case. What is the second case is going to be? Well, it will be when the limit, let's say, when the a value approaches c value, a of our n value is equal to b. So what is this function about? Well, as we can see, so if we write it in a more neat way, where the limit of our a value approaches our c value of a, of our n value is, let's say it is equal to b. as we can see, this value, this formula of our limit system is going to be what we call a sequence. Sequence systems, which is a set of a number that satisfies own equation or patterns. This is what it is going to be. And if we add these two types of function and the sequence, we can call it as the total systems or types of our limits in our rational function. Now, if you think about the basic or the most fundamental differences between the function and the sequence, formulas of our limit will be different by its output and the input. Well, we always mostly need to notate our function value by our f of x, which is the output, and the x, which is the input. And for the a of n, which is a sequence, can always be some variables except for x and f. And also, mostly the sequence, the approachment of our limit is different. For the limit, there are always going to be the x value is always approaching the negative infinite or a infinite value. But for the limit of our function, it can be anything because it is a function. So this is a main difference between the function and the systems of our sequence in our formula of our limits in our rational function. And we finished our first one where we had to talk about the definition types of our limits. So all of the things was basically related to what we call limits. So as we have talked about this, the second thing that we might talk about is what is the graphs and form of continuous rational function. Well, we know what is the rational function, but we don't know what the definition of a continuous is. So the first thing that we'll be talking about is the difference, the term, which is the difference between the limit and the continuous. So if you think about the graphs of our rational function first before you think about the limit and the continuous, because we might be able to explain all of them through our graphs. So what is the most important thing in our graphs? It will be a coordinate plane. Here's our f of x. Let's think about the most basic function of our rational function. Well, what is the definition of our rational function? It was the function that is formed by fractions. So let's just see that the rational function's basic form is k over x. So f of x is going to be k over x. Everyone knows that the values of our graphs will be defined by the value of our k. But what exact value? About the signs of our k value. So we know that there will be two cases where they can be either when the k value is negative value or the k value is a positive value. So let's think about when the k value is a positive value. When the k value is positive value, which is greater than 0, so when it is a positive value, the graph of a rational function will be awkward in the first quadrant and the third quadrant. So this will also be when the k value is greater than 0, where it is a positive value. So here is our two situations where a k value is greater than 0, where it is a positive, and where a k value is greater than 0, when it is a positive value. And what is the most important thing about the limit? The value keeps approaching, but never intersects. So the value of f of x will look something like this. So if you draw it again in a more nice way. So if you draw a first one, a third one, which is look like, they will look something like this, which means the first graph where the k value is greater than 0, it keeps going downward to intersect with the x value. But the most important thing is that they never intersect together, even if it goes to an infinite distance. Never intersect. And for the second one, where it's also greater than 0, it is going toward our y-axis. But the most important thing here is that it never intersect. So now let's think about the cases where our k value is less than 0, which is the negative value. And you will also look right over here where our k value is less than 0, where it is a negative value. So it will look something like this. But before that, if you talk about it, the values right over here and the graph form should always exactly same, but they just translate it. So the graph of our rational function when the k value, which is the numerator, is less than 0 will look something like this. That keeps for the I guess the third one, which is located in our second quadrant. It is keep going toward the x-axis, the negative x-axis, but the most important thing in a rational function is it never intersects. And it is also same thing with our last one, where we will just call it as the fourth one. It keeps going downward to our negative our y-axis, but the most important thing is it never intersect in any kinds of finished distance on our coordinate plane. So these were the 4 types of our rational function graphs in our rational function system, and we're gonna talk about the differences. It will be the third one. The differences between our limit systems and the definition of our continuous that we're trying to deal with in this video. And before you think about it, we need to think about what is the definition of our continuous function. And if we just hear the word continuous, we might think about it as the continue. And the continue is exactly right what we were thinking about in these function systems. The definition of our continuous function is going to be a function that continues, which means it keeps going on based on its own equation or the function that it contains. But there should be a differences between a limit. But the continuous means the function that continues without any broken lines. Without any broken lines, which we're just gonna notate it as the smooth function. And how can you think about this through our coordinate plane? Well, if we just say that the broken line, that means if the function, let's say this is a function f of x, and when it has a broken line, that means we notate it as it have a hole around it. This shows that this function has, the f of x has a broken line. But what is the definition of our continuous function of our f of x? It will be a function that will just notate it in this way, that keeps going on without any circle, without any broken line. This is what we call continuous function. So we might figure out the definition of our continuous, and that is the main difference between a limit and our continuous. So as we talked about the differences between the limit and the continuous, what we are going to do right now is actually go through our question. And before we think about it, we have talked about the types of our limits, and as we think about it, our function is f of x is equal to 3x squared plus 2x, all of them divided by x, which means it is a f of x. So this question is basically about the rational functions limit problem. Unfortunately, there are also cases about the rational function limits. And after we think about it, we're all done. All we have to do is apply our knowledge, or you can say common sense, to our original question. So there are 2 cases. And the cases will be defined by the x values. The two cases will be defined by the x values approachment. What does the input value? We know the x value is our input value. What does the input value approach? What does the input? What does the input? We'll just note it as the x value approaches to. And they will highly divided by whether the number will note it as the n value. And obviously this n value is a variable that gets varies or changes, depends on times, where it is equal to infinite value or it is less than a infinite value. So this will be two cases. And the first case is when the x value is approaching, when the x value is approaching the value that is n value that is less than an infinite value. What is the formula will be? The formula will be when the limit value, when the x value, our input, is approaching a number that is less than infinite value of our function f of x. What is this? What is this going to be? This will be, how do we solve this question? Well, as we talked about this in a lot of videos, all you have to do is reduce, or we can say simplify. Simplify the fractions into the simplest form. So when the limit of our x value, when the x value is approaching the number that is less than infinite value, all we have to do in order to solve that question is reduce 100% reduce this and simplify the fraction to the lowest form. And then what should we do? We need to factor them out. And then that will be what our answer is going to be. Now let's think about the second case. And obviously the second case is a case when our x value, which is the input, is approaching the number that is exactly equal to infinite value. Then the formula for it will be when the limit value of our x value is approaching the number that is equal to infinite of our function f of x. How do we solve this question? Well, 100% when the n value is approaching the value that is infinite value, we always need to solve for the asymptote. The asymptote of our rational function. And we have talked about the definition of our asymptote. And asymptotes, what is the asymptote? It is the opposite word. I don't know, we can just see that asymptote is same with the definition of our limit, where it keeps going toward a specific given numbers, but then it never intersects. So let's think about it. But then we know that this function in this case is f of x is equal to 3x squared plus 2x. All of them divided by x. This is what our function is going to be. So let's actually get through our question and solve what the answer is going to be. So if we go back to our original question, it says, what must the value of our k? What is the k value? The k value is when our x value, which is input, is equal to 0. Now, well, that means what must be the value of our f of x when the x value, our input, is equal to 0 in order to be f of x to be a continuous function. Why did they give us question like that? Because we know that when the k value is when x is equal to 0, which means the function will be undefined when the x value is equal to 0, and that value is going to be k. So that same thing when this has a broken line, which we'll just call it when the x value is equal to 0. What the k value should be for our function f of x. If you want to make this function f of x into a continuous function without that broken line. And obviously, this question is not about the asymptote, because if it was asymptote, they must give us the exact value. But then this question is going to be about when the x value is approaching the n value, the number that is less than infinite value. So we might be able to write our f of x in different way. That will be when the limit, when the x value is approaching the number that is less than an infinite value. We don't know exact value of our f of x. What is our f of x? It will be 3x squared plus 2x, all of them divided by x value. Then what is this going to be equal to? It's going to be equal. Well, we know that the x value is approaching the n value that is less than infinite. So all you have to do is reduce the function to the simplest form, and all I have to do is factor them out. So let's think about how to factor our 3x squared plus 2x over x. And we could figure out that all of the terms including numerator and denominator, they contain our x values. So all I have to do is distribute the x value out of their own terms. So as I've talked about it, we have 3x squared plus 2x over x. And all of them are divisible by x. So that means it will be x times 3x plus 2, all of them over x. I'll just go fastly because we had talked about this in few previous videos. X and the x will cancel out, and as we can see, it will be limit when the x value is approaching our n value that's less than infinite value of f of x, but our f of x is going to be 3x plus 2. But as we can see, 3x plus 2 is same thing with 3x squared plus 2x over x, except this is a simplest form. So right now we have simplified, and what should we do? We need to think about when is a undefined value awkward. When will the undefined value occur? And undefined value occur by the key value, which is when our x value is equal to 0. Now all we have to do is simply input our x value, which is our input value, back to our original limit questions. And if we do it, into our f of x, which is 3x plus 2. If you input our 0 value, you'll be 3 times 0 plus 2, which will be 2. So our answer for this question is going to be 2. And people might ask us, why do we need to reduce the function to the simplest form? Because we know that if there is x to our denominator only without a constant term, we know that if we input 0, this will turn into 0. So all we did is simplified and removed our x value.